For decades, humanoid robots have existed mostly in science fiction. They walked across movie screens, helped astronauts, served families, and sometimes even turned against humanity. In the real world, however, they were slow, expensive, and limited to carefully controlled demonstrations. Most could barely walk across a room without losing balance, let alone perform useful work. But in 2026, that story is beginning to change. For the first time, some of the world's biggest technology companies aren't asking whether humanoid robots will become practical. They're asking how quickly they can manufacture them at scale. Advances in artificial intelligence, battery technology, computer vision, and robotics have converged at exactly the right moment, creating machines that are dramatically more capable than anything we saw just a few years ago. The question is no longer whether humanoid robots are possible. The real question is where they'll appear first, and how they'll reshape the way we live and work. To understand why this moment feels different, it's important to look at what held robotics back for so long. Building a robot that looks like a human is surprisingly difficult. Walking on two legs requires constant balance adjustments. Picking up fragile objects demands incredible precision. Even recognizing everyday environments is far more challenging than it seems. Tasks that humans perform without thinking, opening a door, climbing stairs, folding laundry, or carrying a box, require thousands of tiny calculations every second. For years, hardware improved faster than intelligence. Engineers could build stronger motors, lighter materials, and more efficient batteries, but robots still struggled to understand the world around them. They could follow programmed instructions, yet failed whenever something unexpected happened. Artificial intelligence changed that equation. Modern AI systems can recognize objects, understand spoken language, interpret visual information, and make decisions based on changing conditions. Instead of programming every possible movement, developers can now train robots using enormous amounts of data, allowing them to adapt to situations they haven't encountered before. In many ways, AI has become the brain that robotics was missing. At the same time, sensors have become smaller, faster, and more affordable. Cameras can create detailed three-dimensional maps of a room. Force sensors allow robotic hands to detect pressure with remarkable accuracy. Advanced processors can analyze this information in real time, helping robots move more naturally through complex environments. Perhaps the biggest breakthrough has been the combination of robotics with large AI models. Rather than giving robots rigid instructions, engineers can communicate using natural language. A simple command like, "Organize the tools on that shelf," can be interpreted as a sequence of smaller objectives. The robot identifies the tools, determines where they belong, plans a safe path, avoids obstacles, and adjusts its actions if something changes along the way. This ability makes humanoid robots far more flexible than traditional industrial machines. Factories have used robots for decades, but most are designed for one specific job. They weld the same component, assemble the same product, or repeat the same motion thousands of times. If the production line changes, engineers often need to reprogram the entire system. Humanoid robots offer a different approach. That flexibility could make them valuable across multiple industries. Warehouses are among the first places where humanoid robots are being tested. Instead of replacing specialized warehouse robots, humanoid machines can handle tasks that constantly change, such as unloading trucks, sorting packages, restocking shelves, or moving irregularly shaped objects that automated systems struggle to handle. Manufacturing is another major focus. Rather than replacing every worker, companies envision robots assisting with repetitive, physically demanding, or hazardous tasks. They could transport heavy materials, inspect equipment, or perform dangerous maintenance in environments where human safety is a concern. Healthcare presents another exciting opportunity. Hospitals around the world face growing staff shortages while caring for aging populations. Humanoid robots could deliver medical supplies, transport equipment, assist with routine logistics, or support healthcare workers with repetitive non-clinical tasks. This would allow doctors and nurses to spend more time focusing on patient care instead of administrative duties. Home assistance is another area attracting enormous attention, although it's likely to take longer to mature. Imagine a robot capable of helping elderly individuals with household chores, retrieving dropped objects, carrying groceries, preparing simple meals, or reminding someone to take medication. These systems won't replace caregivers, but they could provide valuable support that helps people live independently for longer. Of course, creating a robot that functions safely inside homes is significantly more difficult than deploying one in a controlled factory. Every house is different, every family has different routines, and humans behave in unpredictable ways. Teaching robots to navigate that complexity remains one of the industry's greatest challenges. Another obstacle is cost. Today's humanoid robots remain expensive to manufacture because they require advanced actuators, sophisticated sensors, powerful processors, and complex mechanical systems. However, as production increases and components become more affordable, many experts expect prices to decline, much like they did for smartphones, electric vehicles, and industrial robots. Despite the excitement, there are still significant hurdles before humanoid robots become part of everyday life. One of the biggest is reliability. A robot working in a warehouse or hospital can't afford to make frequent mistakes. It must recognize people, avoid obstacles, adapt to unexpected situations, and operate safely for hours without interruption. Even a small error could damage equipment or put someone at risk, which is why companies are testing these systems extensively before deploying them at scale. Battery life is another challenge. Walking, lifting objects, and processing large amounts of AI data consume enormous amounts of energy. Engineers are developing more efficient motors, lighter materials, and better batteries, but extending operating time remains a key priority. There's also the question many people ask first: will humanoid robots replace human jobs? The answer is more complex than a simple yes or no. In many industries, businesses already struggle to fill physically demanding or repetitive roles. Rather than replacing entire workforces, early humanoid robots are expected to handle routine tasks while humans focus on supervision, problem-solving, customer interaction, and work that requires creativity or emotional intelligence. As with previous waves of automation, some jobs will change, new roles will emerge, and workers will need to adapt alongside the technology. Competition in this field is accelerating rapidly. Companies around the world are racing to build robots that are smarter, safer, and more affordable. Every improvement in artificial intelligence makes these machines more capable of understanding instructions, learning new skills, and operating in environments that were once considered too unpredictable for robots. The next few years will determine whether humanoid robots remain specialized tools or become as common as personal computers and smartphones once did. They won't suddenly appear in every home overnight, but they're steadily moving from research labs into factories, warehouses, hospitals, and other real-world workplaces. The real breakthrough isn't that robots can walk on two legs. It's that they can increasingly understand their surroundings, make decisions, and work alongside humans in spaces designed for people. That combination could transform industries facing labor shortages, improve workplace safety, and redefine how repetitive work gets done. Humanoid robots are no longer just futuristic prototypes built to impress audiences. They're becoming practical machines designed to solve real problems. And if current progress continues, 2026 may be remembered as the year they stopped being science fiction and started becoming part of everyday reality. As these robots continue to improve, their impact will likely extend far beyond factories and warehouses. The journey is still in its early stages, but one thing is becoming increasingly clear. The future of robotics isn't just about building machines that look human, it's about creating machines that can work with humans, making industries safer, more productive, and more efficient than ever before.